New chapter, chapter 6. We're going to talk about the title of this chapter. It's called, oh my, that's a little too thick. Let's make it like that. That's a little better. It's called Angles of Polygons. Alright, so first of all, before we start talking about the several different types of polygons, I just have this random, crazy looking polygon. But I do want to talk about one particular thing, and that would be called a diagonal, because we're going to use that a little bit here in the explanation, so you need to know what I'm talking about when I talk about a diagonal. And let's do this in another color, make it a little bit thicker. Okay, so if I talk about a diagonal, diagonal is drawn in a polygon that from a particular vertex. It doesn't matter what vertex you start at. You can start at any vertex at all. So let's just start at this one right here. So a polygon, or a diagonal in a polygon, is just a line that connects, or a line segment that connects a vertex to a non-consecutive vertex. Okay, to non-consecutive vertices. Non-consecutive means not next to each other. So for instance, if I started here and I went to this vertex, that would be a consecutive vertex, wouldn't it? Everybody see that? Because it's the one right next to it. So I couldn't do that. A diagonal doesn't go to the one that's next to it. It goes to a non-consecutive. So basically to vertices that are not next to that particular vertex. Everybody got that? So if I start here, I can't draw to here, and I can't draw to here. But I could draw where? Down here like that. So that would be considered a diagonal. There's other diagonals. I could start from that. Again, if I pick this vertex to start from, I want to start here again and go where else? Could go to this one. Is that non-consecutive? Yeah, absolutely. All right, and how many more can I draw, do you think? How many? Just one more, right. Just one more, and that would go to there. So those are my diagonals of this particular polygon. Make sense? All right. That's just a little definition, little vocab on diagonals. Got it? All right. Let's do this. So none of that just happened. So here we go. We're gonna talk about several different types of polygons. What? What about a triangle? And I'll show you what we're going to do in a second. I'll give you the goal, what we're trying to get to in a second. All right, let me just kind of bear with me right here. So here's a triangle. Could I draw any diagonals from either one of these vertices right here?
Nope.
No, because I have to go to one that's not next to each other, right? Well, if I start here, well, that one's next to it, and that one's next to it. There's no other vertices to draw to. So I can't really draw any diagonals in a triangle, can I? But I do want to start making a little list here. This has 3 sides, doesn't it? Okay. How many triangles do I have here? Now, it sounds like a stupid question, but you're going to see where I'm getting with this in a second. So I have 3 sides. How many triangles? I have 1 triangle. Everybody with me on that? All right. Now, let's just draw. You'll see what I'm going to do here in a second. I'm just drawing just some random quadrilateral. Now, this is a quadrilateral, 4 sides. It's nothing. It's no kind of special quadrilateral. Let's see how many diagonals we can draw. All right, and I can start from any of the vertices. It doesn't matter which one you start from. Let's just start from this one right here. So I can only draw 1 diagonal, correct? Okay, I can only draw 1 diagonal, but I want you to see this. How many triangles do I have if I draw that 1 diagonal? Just gave it to him. What do you do with it? No, just tell him no. So how many triangles do I have here? I just handed him a paper 5th period. A worksheet, and he's asking already. I had somebody in the other class come by 5th period. I gave them 1 3rd period, right? Handed everyone 1. He comes back 5th period. Could I get a worksheet? I'm like, no. That's not unfair, do you think? It's ridiculous. Well, he can go on digital lockers and get one. I think that's ridiculous. I think that's crazy. Yeah, all the worksheets are on digital lockers. Anyway, how many triangles? I'm just being a, what do you call that word? Being a, not allowing people to do stuff. There's like a fancy word that people use that, no. Like, when you allow people to do something, I know it is, an enabler. If I just give him a worksheet then I'm being an enabler, aren't I? He needs to learn to hang on to this stuff just 2 periods before. I don't care. The world needs to know that...
Be an enabler.
Yeah, that I'm not an enabler. Here we go. So how many triangles do we have here? I drew one diagonal. Okay, I got 2 triangles. All right, so what I want you to see is this. We're going to make a little list here, and we're going to come up with a little routine. I forget words so bad. It's probably because I'm 47. All right, so 4 sides. How many triangles? 2 triangles. All right. Let's do another one. So I had 4 sides, right? How many sides do you think I'm going to draw now? 1, 2, 3, 4, 5. All right, now let's draw some diagonals in here. Now, just pick one vertex. It doesn't matter which one you pick.
That one.
This one right here? Okay, let's pick this one right here. You like the other one? That's right. We're going to pick this one. So we start here. How many diagonals? I got 1 diagonal here, 1 diagonal here. And how many triangles does that give me? That gives me 1, 2, 3 triangles. And I want us to see a little pattern developing here. So I have 5 sides, and how many triangles? I have 3 triangles. Let's do one more, okay? Let's just do one more.
17 sides.
Well, I'm not going to draw 17 sides, but we might talk about it. 1, 2, 3, 4. This is kind of sloppy. 5. Whoops. And 6. You get the basic idea. I know it wasn't perfect. That's okay. We're running out of time. So let's draw the diagonal. Let's just start right here. So I can't draw to here. That's 1. And there's another one. And there's another one right to there. And how many triangles do I have now? 1, 2, 3, 4. So now, let's list it again. We have 6 sides, and that gives us how many triangles? 4 triangles. Yes, very good. That's what I want you to see. I just want you to develop a little pattern here. If you have 3 sides, you have 1 triangle, right? So how'd you get from 3 to 1? How'd you get from 4 to 2? How'd you get from 5 to 3? How did you get from 6 to 4? You just subtracted 2. What if I had, watch this, n number of sides? What does that mean, n number of sides? What does that mean, n number of sides? Could be any number, that's right. It could be any number of sides. We could say 17, right? You said 17. Could be any number of sides. Okay, Brooke, so how many triangles, if I have n sides, how many triangles would I have? Thank you. See, I gave you a chance. So it's n minus 2, right? Number of what? Triangles. Let's go back to this. Now, this is what I'm going to show you what we're getting at here. What we're getting at is we're going to try to find the sum of the angles of a polygon. You hear what I just said? Jot that down. We're going to find the sum of the angles of a polygon. Now, we already know one of them. We've already learned one of them on a triangle, didn't we? What is the sum of all the angles in one triangle? 180 degrees, okay? So watch, one triangle equals 180 degrees. Agree with that? Let's come down here. You probably already knew off the top of your head what 4 sides was, right? All the angles on 4 sides, but this is showing you why it's true. It's 2 triangles, so it's what? 2 times 180, right? Right? Because there's 2 triangles. Each triangle has 180 degrees. If I have 2 triangles, right, then I've got how many degrees? 360 degrees. And what does that mean? That means that this angle, this one, and this one all add up to be 360 degrees. And again, that might be one that you already knew. If I asked you what do all the sides of a rectangle add up to be, what would you tell me? 360 degrees, or a square, right? But really, any quadrilateral, any 4-sided figure is going to add up to be 360 degrees. All right? We good with that? Those are ones that you're probably familiar with. The next ones you're probably not so familiar with. All right? But let's see what we can do. So how do we find the sum of all 5 of the angles in here? It's what? It's 5 times what? I'm sorry, I lied. It's not 5 times. What is it? There's 3 triangles, so it's what? 3 times 180, right? Okay, so we took the number of sides, and what did we do with the number of sides? We subtracted 2, didn't we? All right, so we went 5 minus 2. Right here, we did what? We went 4 minus 2 times 180, didn't we? To get that. How did we get this? We went 5 minus 3 times 180. And then that tells you the sum of all the angles inside that triangle, the interior of the triangle. And so it's 3 times 180. What's 3 times 180? It's 540. Is that right? Okay. So just add 200, take away 20, right? Isn't that the easy way to do that? Okay. And then you see the pattern, don't you? What's this going to be? This is going to be 4 times 180. And that's 720, right? Because you add 200, take away 20, right? So 740 take away 20 would be 720. And that would be 700. These are all degrees. I should put the degree symbol for these. All right? You getting the idea? Now, I could have just sat here and told you that, okay, take the number of sides, take 2 away from it, multiply it by 180. And that would have been okay. You know, you would still learn it. But I think I like doing this because I think it's a good way for you to understand how we got to this information. Does that make sense? So, if I wanted to find the sum of the angles of a 17, we'll call it a gon, 17 gon, all right, 17-sided figure, right? How would I do that? I'd first of all go 17 what? Minus 2, because that gives me what? How many what? How many triangles are inside of that polygon, right? And then I multiply each of those triangles by 180, exactly right. So I'm just showing you all the work right here just to show you what we're doing. So 17 minus 2 is 15. I don't know what that is off the top of my head. Somebody do that for me. Gabby, you're doing that? 15 times 180, 2,700 even. Good. All right, so that, and what is that number? What did I just find when I found that number? It's the sum of the angles of a 17-sided figure, right? Or a 17 gon, if you want to call it that or whatever. But a 17-sided figure. Do all the sides have to be equal to each other for this to work? No. Okay. I mean, I just randomly drew these, and not all the sides are equal to any of these, are they? All right. So it doesn't have to be all equal to each other, but it just has to be a polygon, and it has to be a certain number of sides. And you can find on any size polygon, no matter how many sides that you have, you can find the sum of the angles of that polygon. And sometimes that really comes in handy, and it's very helpful to us. Question? Yes, it should be. Thank you. Good call. That should be 5 minus 2. I think I was getting ahead of myself and thinking the answer was 3, and I put a 3 there. So you're right. It's 5 minus 2 times 180. Thanks. All right, we good with this? All right. Let's see. Okay, let's draw this one. I'll pause it while I draw it. All right, here's our pretty little picture. And the question is to find all the interior angles. Find what they're all equal to. All right? So I want to find out what angle H is. I already know angle J. I want to find what angle K is, but look at this. If this is 2x and this is 2x, guess what? They're both the same. And these two are both the same. So if I find one, the other one's going to be the same. All right? So it's not really that much work. But what do you think we're going to do to solve? How do you think we're going to set this thing up? That's the most important thing. Alex?
Well, we have to count the number of sides and then find out how many degrees the interior.
Okay, the sum of all the degrees, right?
And then
Okay.
you put all those on one side and then the degrees on the other.
Yep. You got it. Okay, now, notice this. We didn't talk about this, but I think it's kind of plain that the number of sides is the exact same number as the number of angles, isn't it? So if I have 6 sides, I got 6 angles, right? On this one, I have how many sides? 5 sides, so I have 5 angles, right? So what we have to do first, we're going to add all these up, aren't we? And then we're going to set it equal to what they all add up to be. So we have to figure out what they have to add up to be, don't we? So if we don't have that memorized, what would we do? We have 5 sides, so I go 5 minus 2 times 180, and that will give me the sum of all those angles. So that's 3 times 180, and that was 540, right? Okay, so all these angles, this, they all add up to 540. That's really the new stuff. Everything from here on out is kind of old stuff, isn't it? Okay, you should know that they all add up to 540, so with that knowledge, then you could do this. If you wanted to make this a little easier on yourself, You could just go 2x plus 2x in your head, couldn't you? Is that all right or not? Okay, and then let's do the other x's, then we'll do the 142. We could add these up if you wanted to. Just do that in your head, or you could write them out. It's up to you. But that's 6x plus what? 28 plus what else? 142. And what does all that stuff equal? 540. And now you can just do the arithmetic, and then you can solve for x. So that's 10x, right? And then, I don't know, what's that? 170 even. Okay. That's 540. And then, so 10x equals, subtract 170. And that's what? 370? Is that, did I do that right? Okay. Then divide by 10. That's easy. So x is what? 37. But that's not really what they asked for. I mean, you had to find that, but that's not what they asked for. They asked you to find all the individual angles inside of this. What did I say it was? 37? Okay. So all the individuals. So what am I going to do? Plug it in. That's right. So 2 times 37 is what? 74? So that's 74 degrees. Now, without doing any math at all, I know what that angle is, don't I? Now, not all your pictures you're going to have equal angles like this. On this one, it happens to be. And then you do this one. So 3 times 37, I have no idea what that is. What's 3 times 37? 3, 21, 9, 10, 11. 111? Okay. So that's 111 degrees, and this has got to be 111. Oops. Oh, I didn't add the 14. Oh, goodness. Oh, what am I doing? What am I doing? Get that out of there. I want to... Why is it? I'm going... There we go. There. That's what I want. All right. So I add what to it? That's 111 plus 114, which is 125. So that's 125, and that's 125 right there. And there you go. Those are your answers, right? Circle that one, that one, that one, and that one. There you go. That's how you would do something like that. Easy stuff, isn't it? All right. Let's do... did they do... Do they do regular polygons on this one, or do they wait to the next section? They must. I don't see where they mention it. Do you see anywhere where they mention interior or regular polygon? Oh, here it is. Oh, actually, in section 1.6, we talked about regular polygons. I don't even remember that, but let's do this. Let's take this thing. I know I'm going to get a regular polygon out of this. There we go. Now, it's been a while, but we have mentioned what a regular polygon is. Do you remember what that is at all? And I think if you go back to those videos, they said it was 1.6. If you go back to there, I think I might have said something like, okay, this is what a regular polygon is. We're not really going to do much with it later, but in another chapter, we're going to do quite a bit with it. Does anybody remember me saying anything like that? I vaguely remember myself saying it. I do say it a lot. You're right. I do say it a lot about a lot of things, but I might have said it back then, but now is the time where we're actually going to do some stuff with this. So if it's a regular polygon, what's true about it if it's a regular? What makes it regular, Alex?
All sides are equal to
Okay, all the sides are equal and all the angles are equal to each other. So watch. This side, this side, this side, this side, this side, this side. They're all equal to each other, and guess what? All the angles are equal to each other as well. Okay? So this would be a regular polygon. Now, we know how to find the sum of the angles. We know how to find what all the angles add up to be. But let's think a little bit, and we could probably do this without any help from the book at all. We could probably figure out what each of these 6 angles are actually equal to. Okay, not just all of them together. How would you find what each of these individual angles are equal to? Right. That's right. You just find the sum of the angles and divide by how many angles we actually have. Does that make sense? So let's find the sum first. The sum of all the angles. So it's 6, right? So it's 6 minus 2 times what? 180. And that's 4 times 180. That's what? 720? Okay, so that's 720 degrees. Now, if I have 6 angles, I got 6 sides, right? So I got 6 angles. So what do I do with that? divide by 6. That's right. And that gives you, what's that, 120? Yeah, somebody do that. I'm almost positive. Yeah, because 72 divided by 6 is 12, right? Yeah, sure. Okay, so that's 120. So each of these angles, every single one of these angles right here is 120 degrees. All right? Now watch this. We're going to talk about something else. Now, all these angles are inside the polygon. So what kind of good geometry word are we going to say? We're not going to call them the inside angles. We'll call them the interior angles, okay? So far, we've talked about how to find the sum of the interior angles. Now, depending on how many sides it had, the amount of interior angles, it changed, didn't it? Okay? What's kind of interesting is this. I think we'll go back to that in a little bit. That's why I was trying to get my little polygon tool to change. I wonder if that little thing right there. No, that doesn't do that. What's that? Right click the polygon here. That might be it. Let's see. No, it's not doing anything. If I right click on that. Let's click it and hold it. No. I know there's an easy way to make change the sides, and I just forget what it is, and I don't want to spend any more. I want to know the sides, S-I-D-E-S. Like this is 6 sides right here. I want to be able to change it to
Like 10 sides.
yeah, 10 sides or 5 sides or 7 sides or something like that. And there is a way to do that, and I just forget how to do it, but that's okay. Let's just do a triangle. Actually, I don't even have to have a regular triangle in this. I'm going to talk about this. I talked about the interior angles, so watch what I'm going to talk about now. I'm going to talk about, not the outerior, the interior. The interior angles. So I want you to see something. If this angle right here was, I don't know, 60 degrees, we'll just make it easy. If that was 60 degrees, what would this exterior angle be equal to? Be 120 degrees, okay? Let's just say it's equilateral just to make it easy, okay? Everybody with me on that? So watch this. Let's extend this one out and find this exterior angle right here. Well, if this is 60, what's that? That's also, no, that's 120, right? Because it forms a straight line. All right, and let's take this. And if this is 60, that's 120. Now, what I want you to do is I want you to take a look at the sum of the exterior angles. Sum of the exterior angles. What is it? I got 120, 120, and 120, and that's 360 degrees, isn't it? Okay? Not necessarily, okay? But it's not always going to be. Okay, on a triangle it happens to be double the interior, but that really doesn't have anything to do with anything else. What if we had a four-sided figure? Okay, we'll just make it a rectangle just to make it easy for us, okay? Now, what about this? If I extend this exterior is what? If it's a rectangle, that's 90, right? And if I extend this one, that's going to be 90, right? And if I extend this one, just bear with me here, that's going to be 90. And one last one to extend, right? Now, it doesn't just, I'm not just doing this with a rectangle. I just picked a rectangle because it's easy to draw. But this works with any at all. What do the exterior angles add up to that, to be to that? 90, 90, 90, 90. 90 times 4 is what? 360. So look, the exterior angle sum didn't change, did it? It stayed the same. Yeah, I would do some more, but we're running out of time. I want to get to a couple other things, but I could do a 5-sided figure, a 6-sided figure, and keep on going, right? And you're going to find out that the exterior angle sum, the sum of the exterior angles, no matter how many sides that we have, the sum of the exterior angles is always going to equal what? 360 degrees. Okay, the exterior angle sum doesn't change at all. Now the interior angle sum definitely does change. All right, which is, it's pretty interesting to see that that happens. If you start getting a lot of sides, and again, I really wish I could, I'm going to try tonight to figure out how to do that, but if I could show you a polygon with like 100 sides, okay, or then go to 1,000 sides, or then go to 1,000,000 sides, which it wouldn't be able to handle. It starts looking like what? It starts looking like a circle. And what do we know about the number of degrees around a circle? It's 360 degrees, isn't it? So the more sides you get, it starts resembling a circle. So all the exterior angles of any polygon at all was always going to add up to what? To 360 degrees. Isn't that interesting? But the interior angles, now if I had a 1,000-side polygon, the interior angle sum is going to be huge. It's going to be, what, 998 times 180, whatever that is. So the interior angle sum is going to be gigantic. But the exterior angle sum stays the same. Because if you think about it, look, we went from 3 sides to 4 sides. What happened to my exterior angle? It got smaller, didn't it? Okay, you got more sides, but the angles got smaller. Does that make sense? So if I had a 5-sided figure, I've got more sides, but each angle got smaller. So they kind of compensate for each other. Does that make sense to you? Yeah. All right, that's why it always stays 360 all the time. So if you had a side with 1,000,000, or a polygon with 1,000,000 sides, all right, you've got a ton of sides, but each angle is going to be super, super tiny, right? It's going to be really, really small.
Then you'd have to divide 360 by 1,000,000.
That's right. Exactly right. Yep.
Is that only the sum of exterior angles equals 360? Is that only for regular polygons?
No, that can happen. Yeah, see, it was unfortunate I made this regular. That works for anything, okay? They don't have to be regular. It's a good question, but it was just easier with the numbers to do it this way. But you're right. It's not just a regular polygon. That works with any polygon whatsoever. Yes?
Are there any questions like where it's reversed, like they don't show you a picture like a 5-sided polygon that equals 365 exterior angles or anything?
Yeah,
like
they
that?
could. They absolutely could. In fact, let's do this.
Because like they might, I was wondering if they
Yep.
can reverse.
Let's do this. Let's go back to this one right here. Let's get rid of that. Get rid of that. Okay? And we'll get rid of all this stuff. Let's take a look at this one again. Remember the work that we had to do? I just erased it all, but remember the work that we had to do? Actually, let's go back and put it in there. Boom. We had to do all that stuff, didn't we? There's actually a little easier way, I think, an easier way to find the interior angle. And what do you think that would be?
Divided?
It might be taking the exterior angle. Now, we already know the exterior angle sum without doing any math at all. We had to find the interior angle sum by doing some math, didn't we? You follow me on that? We can find the exterior angle sum because we already have it memorized. It'd be nice if you guys would listen. I put up with it all class period and I haven't said a word. All right? It's getting really old. It's just rude behavior is what it is. Thank you. So I already know the exterior angle sum. How many exterior angles are there? If this is 6 sides, how many exterior angles are there? There's what? There's 6, right? Okay. So I've got what? 360 altogether, right? That's my exterior angle sum. If I divide that, now this only works with a regular polygon, okay, what I'm doing right here. If I got 360 and I divide it by, how many exterior angles do I have? 6. What's each exterior angle going to be? It's going to be 60 degrees, isn't it? So if the exterior angle is 60 degrees, and that was easy math, wasn't it? That was a little easier than going 4 times 180. Does that make sense? It was a lot easier going 360 divided by 6. So if I go 360 divided by 6, that's its exterior angle. What's the interior angle going to be? It's 120. And that math was easy as well, wasn't it? It was just 180 minus 60, right, which is 120. And that's another way to find that. So it's actually 2 ways to do this. You could do it with the exterior angle, right, situation, or you could do it with the sum of the interiors. But sometimes the interior angle sum, the numbers get really big and a little complicated. The exterior, only working with 360 every single time, right? And you just divide by how many sides that you have, and then you take that away from 180, and that's your interior angle. Now, that only works with regular polygons, okay? Now, if this was a non-regular hexagon, I wouldn't be able to find each individual angle anyway, right? I could only find it if it's regular. Does that make sense?
Did you put dividers in there?
Did I what? Put dividers?
Diagonals.
Diagonals? No, I didn't.
No,
No, I
said
just
could
used...
you.
Oh, could you...
Like, couldn't you put 3
Yeah, that's. But the reason we wouldn't put diagonals here, because the reason we did it earlier is so that I could now know how to use it. Okay, I don't have to reinvent the wheel every time. Okay, I've already done that whole diagonal thing, and now I can just use the fact of n minus 2 times 180. Okay, that's the only reason why I did that diagonal stuff, because I wanted to go n minus 2 times 180. Now I already know it. I didn't find any. Okay, I already know the fact that n minus 2 times 180 gives me my sum, so I don't have to do the diagonal thing. You ever hear that phrase, reinventing the wheel? Right? You don't have to reinvent the wheel every time that you go out in the car. It's already been invented. Use the the invention that somebody's already made, and don't have. Same thing here. You don't have to do the diagonal thing every single time. We already use that to figure out this little formula. Let's just use the formula now.
So you're not.
Okay. No. Now, the only reason I did that diagonal stuff is just to show you how we got to that n minus 2 times 180. That's the only reason I did all that stuff. Okay, it's not like you have to do that on the test or homework or anything like that. Okay? Yeah, we did. I'll give it to you.
Oh, it's worksheet?
Did you say worksheet?
Oh.
Is it worksheet?
No, it's not. I asked. Is it a worksheet? Here it is. It's section 6.1. This page is 394, 395. And it's 12 to 37. There it is. So this chapter, by the way, we are talking about polygons, but then we're going to talk a lot about quadrilaterals. In fact, this whole chapter is called quadrilaterals. Even though that's not all we talked about today. Today was just kind of a beginning to get us started. But the chapter is called quadrilaterals. Quadrilaterals, four-sided figures. Okay, there's a lot of stuff that we're going to do with four-sided figures. A lot of different shapes we're going to learn and all that kind of thing. Okay, so that's what we're doing. I think you should be able to do all of these now over the stuff that we went over. There was a couple examples towards the end of the chapter that I didn't quite hit just because of time. But if you really need to look at them, you can. I think we covered everything pretty good, though, with that exterior angle thing. I think you should be fine. All right, enjoy it.